In this video, we are going to talk about exponents and scientific notation. So let's go ahead and get started. So remember some basic things about exponents. I can rewrite them. 8 to the 4th power is just 8 times 8 times 8 times 8. 8 to the 3rd power is 8 times 8 times 8. Because this asks me to rewrite it using a single exponent, that means I'm still going to have a base of 8 with another exponent. But I want to go from 2 to 1. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I would write 8 to the 7th power. Now notice that there's 7 eighths, and also notice if I add their exponents, that's 7. Option number 2, I'm going to simplify this so it has one single exponent. This is 1w. And then I'm going to go ahead and take, this is 1w, this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4. This is 1, 2, 3. So remember, I'm just adding these together. 1 plus 5 is 6, plus 4 is 10, plus 3 is 13. So this can be written as w to the 13th power. When I am multiplying bases with exponents, I am just adding their exponent. So if I look at this problem right here, now keep in mind that I can only add the exponents of variables that are the same. So 2 and 7 are not the same. So I'm going to bring them down, 2 and 7, 2 times 7. Hey, I can do that math. 2 times 7 is 14. So we got one more, and times 3. 14 times 3, that's not one I know off the top of my head, but I can grab a calculator. 14 times 3 is 42. So 42. Now if I look at my variables, I've got these right here and right here. There's 9 here and 1 here for a total of 10. So I'm going to write v, a total of 10 v's. And then I'm going to write u's. I know I have some u's to combine. I've got 6 and 8 for a total of 14. So this right here would be my final answer for simplifying those exponents. Let's look at another type of problem. So on the last problem, I had a multiplication. So like I had w to the second times w to the second. On this problem, notice there's no multiplication. I just have these parentheses and an extra exponent, no extra base. When that is the case, what we have is a power that's being raised to a power. And I'm not going to add my exponents because really what I have is 7 to the 3rd, repeated 7 to the 3rd, 7 to the 3rd, and 7 to the 3rd. I've got 4 of those. So in order to simplify, I'm just going to combine 3 plus 3 plus 3 plus 3 is 12. So 7 to the 12th power. Now notice I could have just multiplied. 3 times 4 is 12. So let's take that into account for this problem. It's a power to a power, so I just multiply and I have z to the 16th power. What's this going to look like as soon as I have a number? That means if I have more than one thing in my parentheses, I'm going to raise them both to the 4th power. So 3 to the 4th power and y to the 4th power. And I do that because there's no exponents to begin with. Technically, they're ones and I need to multiply those. So 3 to the 4th power and y to the 4th power. Now, one thing we could do to simplify one step further would be to do 3 to the 4th power, which is 81. But those two are equivalent. I can write either. Let's go ahead and try this next one. So we've talked about multiplying and we've talked about powers to powers, but what do I do when I have a fraction? Now remember that if I have the same variable, or the same factor, I should say, on top as I do on bottom, if I have the same factor, then I can cross out those common factors. So notice that there's a b on top and a b on bottom. I can cross out those common factors. A and c are not common, so I'm going to leave them. I'm going to recreate this new fraction. I'm going to make a on top and c on bottom. Now, if I look at 14 and 49, right now those don't look like common factors, but remember that 14 is made up of 7 and 2, and 49 is made up of 7 and 7. So I really do have a common factor of 7, and I can cross a 7 off the top and a 7 off the bottom. And that leaves me with this fraction, 2 times a over 7 times c. So let's check a kind of a similar problem. Hey, I've still got another fraction, and I want to simplify. So I've got 5 times 5 times 5 times 5 times 5. My goal when I have fractions is to cross out common factors. So I have a common factor of, I need 6 5s. Sorry, 1, 2, 3, 4, 5, 6. Perfect, now we're good. If I have a common factor of 5, that means I can cross 1 off the bottom and only 1 off the top. The rest will remain, and that's going to simplify it to 5 to the 5th power. Now notice what really happened was I had 5 to the 6th power and 5 to the 1st power on bottom. And when I have common variables or numbers with bases that are the same, all I have to do is take my exponents and subtract. 6 minus 1 was 5. Now be careful, because on this problem, I still am going to do 6 minus 1. But notice what happens. I have 6 x's on bottom. 1 crosses out on top. And when I write my answer, those x's that are left over, they stay on bottom. They don't go to the top. So when I simplify fractions, I always look to see which one's bigger, 1 or 6. I would put the x's on bottom. There's 5 left over, and if there's anything remaining, it's a 1. So that's just 2 ways to kind of think about that same problem. So let's look at another example. Remember, we're thinking common factors. Well, these are definitely common factors. I've got w's and w's. There's 2 on top and 6 on bottom. I kind of think of it as a war. If they go to battle, the number on bottom is going to win because it's bigger, and it's going to win by 4. These are all going to be gone if they were in battle together. 2 of these disappear because they cancel out with the ones on top, and I'm left with 4. Now, 48 and 8 don't look like common factors, but remember, 48 can be made up of 6 times 8. So that common factor of 8 is going to cross out, and I'm left with 6 on top. That's the only thing left, and w to the 4th on the denominator. So let's try that again. I've got 5s. They're same on top and bottom, so nobody wins the war. All of them are gone. If I look at b's, the top is going to win that war. So I'm going to put b on the top, and by how much? They go to the battle. The difference between 3 and 2 is 1. So I have b to the 1st power. There's no common factor of 3 on top, so I'm going to leave the 3 on bottom. And that's it. Now, one common way to simplify that would just be, say, b over 3. Okay, now what is it that I'm going to do with negative exponents? So the thing with negative exponents is I need to move them before I do anything else. So what I'm going to do is I'm going to move this negative exponents to the denominator. So what that's going to look like is I have a fraction bar. I'm going to have 7 to the 3rd that was already there and 7 to the 5th. When everything goes off the top, I have to put a placeholder of 1 so that this remains a fraction. Now that these are both in bottom, I can use my rule of, hey, there's 3 and there's 5 7s for a total of 8 7s. And that 1 stays as my placeholder on top. So let's try this one. So right now I have 2 negative exponents, and I don't have a fraction, but I'm going to draw it in. And I'm going to say, right now there's an imaginary placeholder of 1. And I am going to move those 2. So I'm just going to have my new fraction. I'm going to have 8 to the 3rd and 8 to the 6th. My placeholder now switches to the top on top, and I am left with 1 on top, and 3 and 6 make a total of 9 8s. Okay. If I have a negative power, I'm going to deal with the parentheses first. I always work outside to inside, so don't deal with the negative until you get rid of those parentheses. So remember to multiply when I have a power to a power. So I have x to the negative 14th. I see a negative exponent, I make a fraction, and I commit it to the downstairs. So I'm going to send it down there, and a placeholder of 1 goes on top. So 1 over x to the 14th. Okay, so let's look at, that's exponents. Let's take a second and look at scientific notation. So remember scientific notation. I have the number in front is a number between 1 and 10. And then I have times 10 to a specific power. Remember when we times by 10, all I have to do is move my decimal point. So right now I have 6 point nothing. Timesing it by 10 is going to make my number bigger because it's a positive exponent. So I'm going to move my decimal 4 spaces, 1, 2, 3, 4. I'm going to move it to the right, making my 6 turn into 1, 2, 3, 4, turn into 60,000. So let's talk about the reverse. Well, if my exponent is negative, that means I need to make my number smaller. So instead of 6, instead of moving it to the right, I need to move it to the left to turn into a decimal. So 1, 2, 3. Add in our zeros, and my standard notation is 0.006. And I know, just put that extra 0 there because we always put a 0 in front of a decimal place. Okay, so if I'm converting this back into scientific notation, now make sure when you move your decimal that you move it so that you only have one number in front of the decimal. So I have an 8. I don't want an 84 and I don't want an 845. I just want 8, and then 2 decimal places are okay. So if I'm converting it right now, I have my decimal point right here, and I'm going to move it 1, 2, 3, 4, 5, 6 places so that it says 8.45, and all of the zeros I can leave off because it doesn't give me any extra information. So 8.45 times 10. Now count how many times we moved it. 1, 2, 3, 4, 5, 6. 1, 2, I did not count very well. 1, 2, 3, 4, 5, 6. Okay, so 6 times. Now, because my number was a large number, that means my exponent's going to be positive. If I looked at this one, I see that my number is really, really small. That means when I write my times 10 to the something power, it needs to be negative because I want a smaller number. Where do I want to move my decimal? Between the 7 and 8, so I have 7.834. How many times did I move my decimal to get there? 1, 2, 3 times. So it's going to be 7.834 times 10 to the negative third. Okay, so last couple problems. This one's going to talk about like a word problem. So we have an astronomer, and their infrared telescope is able to detect radiation at a wavelength of 7.68 times 10 to the negative 6 power. Write it in standard notation. So I want to get rid of the scientific. As soon as I see that's a negative exponent, I know that the number that I'm going to be converting to is going to be a small one. So I'm going to go to my decimal point. If I want a smaller number, I'm going to move my decimal to the left. I'm going to move it 6 times. So 1, 2, 3, 4, 5, 6. That's going to give me 1, 2, 3, 4, 5 zeros. So I have 7, 6, 8. The next one says the diameter of Uranus at the equator is approximately 51,100 kilometers. Write this in scientific notation. This is a big number, so when I write my times 10 to the something power, it's going to be an imaginary positive. Where do I want to move my decimal? I want to move it right here between the 5 and the 1 so that I have 5.11, not 51.1. So I want the number that's smaller than 10. So here we go. So I'm going to write 5.11, and then I need to count how many decimal places. 1, 2, 3, 4. It took me positive 4 to get over to that 5.11. Last two problems are going to have me do some calculations with scientific notation. Now with multiplication, all I have to do is multiply the numbers in front. 2 times 2 is 4. And multiply my common bases. So 10 to the 9th and 10 to the 2nd all I have to do is say there's 9 tens and there's 2 tens for a total of times 10 to the 11th power. If I'm adding or subtracting, I'm not going to combine the exponents. It's kind of like combining like terms. All I'm going to do is combine what's in front. So 5.6 minus 5.4. And I can do that because my bases are the same. So 5.6 minus 5.4 is 1.2. And I bring that base down. So times 10 to the 4th power. And that's it. If you have any questions, please feel free to reach out and have a great day.